All right, so in this video, we're going to start working our way through what are called the toolbox functions. So these functions are kind of like the building blocks for most of the other functions that you're going to run into, except for exponential and logarithmic. And so you want to make sure that you are familiar with their shapes and domain and range also. So we'll say toolbox functions. So the first one is y equals a constant, such as y equals 3 or y equals -2 or whatever. And so we've got an example of one here. I haven't labeled the axes, so it really could be anything, just about. So our domain, of course, is all real numbers. There's no divide by 0. There's no square roots to worry about negatives under. And our range is very limited. It is just whatever the constant is. So we'll just say that the range is whatever the constant is. Just say that. All right. So next up, we got a little bit more complicated, right? We've got y equals x to the 1. And actually with our constant, we could think of this as y equals x to the 0 plus b, right? Which is just the plus b part. Now we are going to, there we go, as soon as I find my mouse, move over to y equals x. So this is really a linear function, of course. Domain, again, all real numbers. Range this time, because we're not a constant function anymore, is also going to be all real numbers. So we're going to talk later on in this chapter about transformations, which would be vertical shifts or vertical stretches that would change the slope. And so really we can think of this y equals x line, which can sometimes be called the identity function, which is what I started writing. That we can take this identity function and put some transformations onto it and come up with any other linear function. All right, so next up is our quadratic, our basic quadratic function. And again, we can get to any other quadratic function through vertical or horizontal shifts, stretches, and reflections. And so, again, this one, there's, again, no divide by 0 errors or things to worry about, no square roots. So our domain is, again, all real numbers. Now, the range for our baseline function, which really, we've gone 2, sorry about that. Of course, we're doing y equals x squared, so our range, our lowest output value is 0, and it's going up from there, so 0 to infinity. Our next one up is the cubic, and you'll notice, right, it looks kind of like our quadratic, except that half of it got reflected downward, right? So we have the function exists for all real numbers for the domain. And for the range, if you think about starting from the origin, it goes all the way up and it goes all the way down. So our range is also all real numbers. So these are just the shapes that we kind of expect you to know these general forms. So next up is our square root function, which my computer is again not liking us. All right, here we go. So this is square root function for obvious reasons, because it's just y equals the square root of x. Now this one finally has a domain that's a little bit different, right? Because we can't take the square root of a negative number without introducing imaginary numbers. So our domain, we're going to start at 0, and it's okay to take the square root of 0. So that's included, and it's going to go out to infinity, but no negative numbers. And you can see from our range, square roots when we talk about the function. So by definition, the square root function, this is versus the operation, the square root function is only the positive square root. And we do that because if we didn't, it wouldn't be a function. Right? So our range, same story here, the lowest value we're gonna get out until we've done some vertical or horizontal transformations, translations, is gonna be 0 to infinity. So you should know that shape. Let's see, I think we can get through all of these in one. So next up we get our cube root. So this is asking really what number can I cube to get the number under the radical. So for instance, the cube root of 8 is 2, just as a reminder. Now, and the cube root of negative 8. What number can I cube to get negative 8? Well, negative 2. So this one doesn't have the problem that square root does. You're not going to introduce imaginary numbers with any odd roots, because if you raise a negative to an odd power, you still get a negative. So this one we're going to have domain being all real numbers, range being all real numbers. Then we've got 3 more and we're at 6 minutes. You know what? Let's go ahead and take a break for our last 3.